All right. Uh, so yeah, it's 10:05, so I tend to get started as close to on time as possible. Welcome to the class, COMP2404, Introduction to Software Engineering. I hope you had a great summer, and your last semester went well, and this semester is off to a good start. Um, so I'm Daryl Hill, the instructor, and let's talk about the class. All right, so as you may have noticed, I'm recording the lecture on Zoom. All right, so I like to give you guys as much flexibility as possible for consuming this class. Okay, so I liked showing up to class because, well, sometimes you already know the stuff, it's kind of boring, but often stuff is given to you that you wouldn't have otherwise come across. But at the same time, I also like to review old lectures, and when I do that, it's nice to have the video and do it at, like, 2 times speed or something like that. All right, so I like to give you guys as much flexibility in consuming this. Now, this is, of course, a double-edged sword, right? Because you can get into the habit of saying, oh, well, it's recorded, I'll just catch up on them later. If you start falling behind, it's a very bad idea. You tend to stay behind if you start falling behind. I give this to you, hoping that you use it responsibly. Okay, so that's sort of one of the themes of this class is that, so in the first year, we hold your hand a lot. We try to make you engaged in the class. And this year, sort of, we, I guess, take the training wheels off a little bit, right? So you guys are going to be more responsible for things like meeting deadlines. So lectures are live and in class, but also recorded over Zoom and posted to Brightspace. Tutorial sessions are weekly workshops where you may work on classwork, get TA help. So yeah, there's a bunch of tutorial sessions. You have signed up for one. Presumably you can make that one. You don't have to attend. But there's actually 3 other ones, and you can attend any one you like. Okay, so we have not run into problems where we've had too many people in the tutorial. If we ever run into that problem, we'll deal with it, but so far so good. So yeah, feel free to attend whatever tutorial you like. So the idea that we are moving towards in this class is that tutorials are basically like office hours. They're your group office hours. So you can go, you don't even have to do anything. You can just work on your things, work on your assignment, work on your tutorials. And if you have a question, the TAs will be there to help answer it, or you can ask yours, right? So that's sort of the idea of how they should be used. Attendance is not required there, but it's a good resource. So hopefully you put it to good use. Tutorial sessions are not to be confused with tutorials themselves, which are weekly programming assignments. Completed on the OpenStack submission server. So don't get OpenStack, don't worry too much about that. It's just a web page. Okay, so I'm hosting it on OpenStack. That's the only reason why I call it that. That's separate from if you sign your own OpenStack, that's completely different. Okay, this is just a web page. You're going to put in a URL, perhaps using the VPN, like off campus, where you can submit your work. And probably next week, I will go over an example of that. But for now, yeah, so we used to have Gradescope, right? Maybe some of you have used it. I used it. I loved it. It was great. And then I was just early summer, I was teaching a course. I was planning on using Gradescope, and I got an email saying Gradescope has been discontinued. It's too expensive, right? I mean, all that quality comes at a price, and we couldn't afford it. So I made my own. So yeah, that's why it's on OpenStack, and it works pretty well. Assignments will be programmed using C++ and uploaded to Brightspace. Okay, so the tutorials are auto-graded. So you submit them to the, get your mark back right away. And then you can see all your marks, and then the highest mark of whatever you've submitted will be your mark. I really like auto-grading, especially for computer science, for programming classes, because, well, half the time, or like maybe the majority of the time when you write code, you're writing for another program, right? To an API. You're using a library. So you have to get things precisely right, as defined by that API. And so this is good practice for that, right? So you have a bunch of tests that get run on your code, and you have to pass those tests, basically. So tutorials are completely auto-graded. Assignments are partially auto-graded. About 2/3 of your marks are for just functionality. Does it do what it's supposed to do? Okay, so there'll be tests that will run on that. You'll have access to those tests, so you'll know your assignment mark mostly going into it, and about 1/3 of your mark is the TA through your code and making sure you did things how we asked you to. Okay, so that you didn't cheat, well, cheat's a strong word, but you didn't like use a library that you weren't supposed to and gain some unfair advantage. Okay, in particular, vector. So I guess let's talk about some ChatGPT and large language models. So that is one of the signs of that you used ChatGPT to do your assignment, because we strictly forbid you to use the vector on the first few assignments. And some people have these beautifully written assignments with vector in them, right? Which means that, well, probably you didn't read the spec, which told you not to do that. And you just asked ChatGPT to generate it. And that's what it did, because typically, if you're to these problems, you would use a vector. But we're making sure that you don't, so that we can teach you some other low-level lessons. Okay, so if that happens, the auto-graded mark will be reduced, right? So yes, you will know your mark going in, as long as you haven't broken any rules, in which case you will be penalized. Using a vector is actually a big penalty, okay? On the first couple, later on we'll use it, but after we learn how it works. TA office hours will be posted on Brightspace once finalized this week. No office hours, no tutorials. That will all start next week. But mostly tutorials, right? The midterm will be in person during class, and the dates indicated. The final exam will be in person. So really, I mean, since the lectures are recorded, you don't have to show up. I like it when people show up. That's great. It's a little more interactive. I've never had to lecture to an empty class yet, but it's come close on like snow days. So you don't really have to show up. I like when you show up, but for the midterm, you have to show up, right? Of course, you can miss it if you're sick. And I will outline the details for that, but that's the one place where we do expect you to be in person, and you will be writing code, especially on the midterm, by hand. Right, so you'll just be handwriting code. So it will pay to learn how to program and not rely too much on code generating tools. All right. So we're going to learn object-oriented software development in C++. We're going to learn, basic language features. So a lot of this is going to be review in the beginning, but I did skip it one semester, and when I skipped it, I had a lot of questions after, like, well, what happens here? And I'm like, oh, okay, well, I guess I should review it. So there's going to be, a bunch of repeated stuff that you've seen before. Basics of object-oriented design, UML class diagrams. So essentially, and encapsulation, inheritance, all that stuff. Stuff you've seen before, but we will talk a little bit more about content in a minute. Strategies for memory management. Memory management is big. All right, in C++, in a level systems language, like sort of memory management is almost exclusively what separates that from high-level languages, right? Because if you manage memory, then you can fine-tune a lot of stuff and write really fast code. And if you're using a garbage collector, then when that runs, your code slows down, and you don't really have control over when that happens. Program organization for testing and debugging, design patterns. All right, so you need a C- in this class if you want to take 3004, and you need 3004 to graduate. So if you're in computer science, you're aiming for a C-. The evaluation, tutorials, best 9 out of 10. And generally speaking, you should do the 10th one as well. Generally what I do. And also, if you ask, like if you're on the edge of a letter grade, and I get all kinds of emails saying, well, can you bump up my grade? Well, I go and look and see if you've done all the tutorials. I look at an advantage of all the ways that you can actually increase your grade yourself. And if you haven't, then I kind of like, well, you're stuck with what you get. And if you did, then you probably don't need my help anyway. But so yeah, consider doing all 10. It will help your grade. Assignments, there's 4 of them. I don't like dropping one, but I do appreciate that sometimes life gets in the way of putting forward your best effort on an assignment. And so the three highest assignments were worth 10% each, the lowest was worth 6%. That's the compromise I made. And, plus you can on there do poorly on an assignment, and I'll most likely do what's that called? WooClap. So WooClap, you can participate here or from home, and you get graded on participation, not correctness, because I actually ask questions that sometimes don't have a correct answer. It's just to help us think about things. But yeah, generally like 1.5, 2% bonus for that as well. Okay, so if you're looking to increase your grade, or if you're looking, to make sure that you don't land just short of an A, I would suggest participating in the WooClap and doing all the tutorials. Yeah, midterm, final. Questions so far? Okay. The midterm, did I get that right? Wednesday, October 29th, Thursday, October 30th. Yeah, so this is us. So that's the midterm, it's just after the break. Yeah, so it is not possible to write the midterm remotely. There's some stuff about e-proctoring we're probably not going to. That was back when we still had Gradescope. We don't have Gradescope, and I'm not confident. I'm pretty confident in my submission server, but not confident enough to like completely wreck a midterm because something goes wrong. So the midterm will probably be handwritten, no e-proctoring and stuff like that. But you can't write it remotely. The only thing you can do is if you're there is a service. If you're more than 160 kilometers away, you can pay $100 and then go to a university close to you, and somebody will watch you write the midterm. And that's a viable option, but COMAS is not, right? I asked the COMAS people because I said, well, what happens if you suspect somebody of cheating? Like if they, you tell them to, they don't turn on their monitor, or if you can see them like actually looking off to the side or something, so you suspect they're cheating, like what can we do? And they said, well, nothing, like we can't prove it. And so it's just, COMAS is supervised cheating, and so we're not gonna do that, okay? So you have to have somebody watching you write, preferably you will be writing here. Completing tutorial, no exceptions are made for missed tutorials. Assignments are mandatory, and we don't accept late assignments, okay? Meet the deadlines, please. Just manage your time. You can do it. I mean, once upon a time, when I first started teaching, actually I used to do this in 1406, make the assignment due on Friday, and Monday was the late due date, and if you handed it in on Sunday, it was minus 20%, right? Minus 10% per day. For this class, I just make it due on Sunday. Aim for Friday night, and then make sure that you're finished for Sunday. Late assignments are never accepted because it's a lot of logistics for basically the people who submit late assignments tend not to do very well anyway, right? So even if I give an extension, those people tend to sort of fail the assignment. So it's a lot of wasted energy for nothing. It's your responsibility to ensure that all your marks are posted to Brightspace or the submission server are correct within 1 week, right? Otherwise, at the end of the semester, everybody comes and tries to argue for all their marks. So please, please, please check your marks. Make sure that you are satisfied within 1 week. Okay. Laptop requirement, I'll leave you to read that. You guys should all have laptops, right? You should have your own laptop. There are ways to borrow them if yours breaks. E-proctoring. I put this in just in case, but like I said, I don't trust my submission server that much that I ruin a midterm. So probably we're not doing e-proctoring. Collaboration, no collaborating on tests. But yeah, for sure, talk about these problems with your colleague or fellow student, right? So don't shut yourself up in the basement and program unless you actually love to do that. Then of course, go ahead. But feel free to talk about these things and share solutions verbally. Like, have you tried this? Or did you check to make sure that you dereference the pointer, whatever. You can talk about these things. All right. Academic integrity and more explicitly AI, I guess. So my official stance is that you cannot use AI on the assignments, and I know it can be very tempting, but if I were you, I would hesitate to use it, right? The purpose, you want to learn how to program. I know it makes it easier and it sometimes comes up with full solutions. But if you like graduate this class and then graduate from your degree and you get a degree and you don't know how to program, like you've really done yourself into a really bad hole, okay? Because large language models are very good at solving the problems we give you in university because these are very simple problems and they're well documented. They're all over the internet. But get out real world, nobody's going to pay you money to solve problems that are already solved. So they're going to pay you money to solve new problems. And large language models are not going to be as helpful with that, right? They are great for like looking up syntax, like the days of not knowing the syntax of a programming language and that making a difference are probably over. I wrote this submission server in Node. I don't know a thing about Node. I do know how servers work and HTTP requests and GET and POST, but I never used Node before, but that really wasn't an issue because I just said like, hey, how do I do this in Node, right? And so they're very great at that. But I also double check all the code. Like which editor? So we're going to talk about which editor and how we set up our programming environment. We're going to do that after we take this. But yeah, Visual Studio Code is sort of the recommended way. Again, we're going to in a Linux environment or sort of Linux compatible, but we'll talk about that very shortly, actually. So yeah, officially, don't use ChatGPT. Unofficially, like, there's no way to, I can sort of like, I've used it, but I can't prove it unless your comments say something like, I am a large language model, right? So, I mean, you guys are kind of have to try and be responsible. Use it responsibly. Officially, you're not allowed to use it, but again, there's no way I can prove that you've used it unless you do something really obvious. But yeah, keep in mind that you'll be handwriting some code on the midterm and final. Places like Chegg, Course Hero, One Class, I don't know if those are, you know, this might be an old list of outdated services. I don't really pay attention. But these are always considered misconduct, so please don't post our assignments or tests there. All right, missed midterms. Here, this is actually out of date. There's a website that you're supposed to fill in, but I will, closer to the midterm, tell you exactly what I expect of you. Okay, so basically, I don't ask for this anymore. I might ask you to fill in the website because then we have a record of, you know, how many people are missing midterms and things like that. Yeah. There's a lab. I think they are moving towards laptops. They're taking out the actual desktops. I have a code, mouse machine to SSH. Yes, so whatever setup you have for 2401 will almost certainly be good enough for this class. Okay, it's basically the same thing. We will talk every class, like so for the first few lectures, I will show you a different setup that you can use. And then talk about some other setups that you can use. But yeah, that is, if you have something set up for 2401, that will work just fine. I mean, I can't imagine a scenario where it would. All right, so that's all basically the class stuff. Any questions? Yeah. Pen and, sorry, I didn't quite catch all of that. Pen and paper, yeah. So someday I hope to do, so although COMAS is not great for, you know, I don't think it has any teeth when it comes to proctoring a midterm, I think it's great if you are located in class using COMAS and then people are walking around, and then the combination of those two things. Because what we really want to prevent is if you're in class and I can see you typing on your computer, then I can verify you don't have your phone open or something like that. But also, like, COMAS basically takes a bunch of screenshots of things that you do, so somebody can look at them later and say, oh, you did what you weren't supposed to. So that's my sort of dream for this class, is that someday the midterm is you actually coding on your computer. Because that's, I mean, the goal of this class is for you guys to be better at that, right? So not necessarily better at writing down code, but for now, yes, it's going to be handwritten. Again, sort of dropping grade scope. I had planned on doing that this semester, but when we lost grade scope, I changed my mind. Yeah. Yes. Oh, yeah, for sure. They'll be practice. It'll be very close to what you'll get on the right. So yes, I'm not trying to trick anybody when I make a midterm. I'm very transparent about what's going to be on it. You just have to study basically and know how to answer the questions or something very similar. Other questions? Okay. In addition to all of that, well, there are tons of resources at the school, right? Because we're not just students for learning. You guys are also people, and you know, you're hoping to get more out of, well, more than just what you want to get out of this class. So the undergraduate academic advisor, if you're wondering what courses should you take and what is, you know, if you want to, if your goal is X, what do I have to do to get there? These are the people to ask, right? They're very, very knowledgeable and they can help you out. So I highly advise you to direct any questions their way. There are also, again, right? So some of you are away from home for the first time or whatever. Maybe you're still living at home, that doesn't matter. But there are a ton of resources at the university to help out students, right? And I suggest you use them. You guys pay good money. If you need them, please do use them. So I'm not going to go into all of the details here. Suffice to say, this is just sort of a very basic snapshot of things that you might need. There are a lot more resources, and I believe I have a pamphlet kicking around, although I'd have to look for it. But I can always, I know where to get one, right? So if you do need help, if you do need resources, you can ask me or somebody else, and we can direct you to the right place. Okay, so that, I believe, covers all of the course outline. Let's briefly look at the calendar. So generally speaking, we get off to a bit of a slow start, right? Nothing this week. I will try and release the tutorial. I got a pretty busy Friday, but maybe Friday, or if not, actually the tutorial will be out before Monday. Assignment 1, hopefully also before Monday, but maybe a couple extra days. All right, so tutorial 1 here will be based on some of the stuff that we see today, actually. We're going to, once we get into the lecture, we'll look at sort of the first steps on how to compile a program. And that will be tutorial 1. And then basically, tutorials are due Saturday at midnight. Now that's a soft deadline. So the submission server does not have, because I wrote it myself and I'm still adding features, it doesn't have a hard deadline, right? The deadline is whenever I wake up and make that tutorial invisible, which is probably, you can probably guess, around 8 o'clock or something like that. Okay, it's a hard deadline though. I wouldn't try submitting at 9. It'll be gone and I won't really be allowing anybody else to submit after that. All right, so try and get it done Saturday night is, I guess, the point of that. The assignments will be due Sunday night, and again, it's a soft, is it a soft deadline? It's a soft deadline, but it's on Brightspace, so it's a soft deadline followed by a very hard deadline abruptly at usually 8 a.m. And if that's, you know, don't miss that. Midterm just after the break. And yeah, that's it. Questions on that? Okay. All right. I have no idea. So the last class went really slow because Windows was acting up. So let's see if but it may have been because my Dropbox was updating. So anyway, let's see how fast this goes. So the goals of this course are, well, you want to become a software engineer, you want to write code. I put here that people will pay money for. That's sort of like the glib answer. But really, you want to write programs that other people find valuable, right? That's useful to other people. So we're going to aim to make you better at that. And how we're going to make you better at that? Um, well, we're going to try to make you more technically adept with the language, with memory management, with low-level systems programming. And we are going to start talking about good software engineering practices as well, right? So what is a good design? What is good documentation? How would you test this? We're going to start talking about those things. We won't get too deep into them. 3004, you're going to do a lot more documentation and design. And then if you want, you can take 4004, which gets into quality, deeper into testing. This will just be an introduction to all of those things. And we're going to, this is a continuation of 2401 and sort of preparation for 3004. 2401 uses C. 3004 usually uses C++, and we're going to use C++. So this is going to help you learn it so that you can apply it to something bigger in 3004. But before you get all excited about learning new stuff, like we're going to retread a lot of ground that you've seen in 1406. Right? So we're going to look at object-oriented programming, except we're going to do it from a systems level perspective. So we're going to pull back the curtain on things a little bit. We're going to say, yeah, we made a class, we made an object, but what does that compile to? What does that look like in memory? Right? So we're going to basically help you understand languages like Java and Python a lot better, right? Because what happens is these are great languages, they're very easy to use. And then occasionally when you're using them, they do something that you don't expect. And then you're wondering, like, why isn't this doing the thing that I think it's supposed to do? Few insights, and then when you read it, it's going to go into detail about how memory is managed and things like that, whether it's copied or whether we just copied a pointer. And so this class will help you understand those explanations. So this will give you a deeper understanding of programming. So we're going to go lower, but also higher. Right, we're going to talk about programming from a higher level, the best practices. What is an API? What makes a good API? Things like that. All right. So for the low-level stuff that we're going to be taking, we're going to be looking at C++. And basically, right, so any software stack that you work on, you basically have, at the bottom, you have hardware, right? Everything runs on hardware. And then, I guess, let's put an honorable mention. Let's mention assembly language, because essentially that's what everything compiles into. And then, well, up here you have your basically very nice high-level language that doesn't require memory management and things like that to write your application. And then between the assembly and the Python, we have our we have a pen that's not quite working. All right, well, you have C and C++. Right, so you have that systems level layer. It'd be nice if I did not have technical difficulties. All right, well, yeah, so in between that is your C++ layer, right? So that's basically, we do have high-level constructs in C++, but we tend to use those to sort of help control the low-level stuff, right? So this exists everywhere because, I don't know what happened. Well, I guess I might be out of a That exists everywhere because basically, all the high languages you use, like JavaScript and Python, those are written in C and C++. And so at some point, you don't have to worry about the memory, but at some point somebody does. And that's usually these guys, right? I also liken it to, if you've ever seen the Titanic movie, it's very old now, but I did like how they did I don't know if you liked it or not, but I liked how the contrast between the first class passengers, right? They're living in luxury. These are the Python and JavaScript programmers. And then they would show occasionally the people in the bottom of the ship shoveling coal into the engine, and that's your C and C++ programmers, right? There are the people making the actual work, I would say, but that's not quite true. But so yeah, AAA gaming uses C and C++, GPU programming, device drivers. If you want to make your own scripting language, which you can, right? People do this. Godot did that. Godot is a game engine. They wrote their own scripting language. Guarantee you they did that in C and C++. And basically anywhere that performance matters, you're going to be digging into this level. All right. Now, so that's the low-level stuff. On the high level, we're going to talk about software engineering. So what is that? Well, software is always changing, right? So everything you have, every app you run updates periodically. If it stops updating, eventually it's going to go obsolete because it talks to a lot of other services and things that are also being updated. Shout out Godot, yeah. You like it? It's pretty good, yeah. We were trying to, me and my son were trying to put together a game. Ran into some bugs though, but that's what you get with, they are sort of a maturing in the 3D. So they're very good at 2D, but in the 3D, they're maturing still, I think. Yeah, so very rarely does code exist in a vacuum. So your software is always updating. And so what does that mean? Well, we kind of want to make updating code easier. It means working code is not enough. Working code is necessary, but let's say not sufficient. So we also want our code to be extensible, modifiable, maintainable, adaptable. These are all fancy words for we're going to change things about it. Add features, fix bugs, update interfaces, things like that. And to do all those things, we generally use abstractions. So we put an abstraction layer. These abstraction layers separate one part of our code from another, which means we isolate changes, right? So what we want to have is when I go to make a change or a bug fix, I have to go to 12 different places in my code because I haven't, let's say, the very easiest abstraction is to put it into a function. And if I haven't done that, then I want to change the behavior of, say, loading a file. Then instead of just changing it into the one place, the load file function, I have to go everywhere where I put that. So that's kind of, these abstractions help with changes. All right, so the asterisk, we're here to learn good design and programming practices, but poorly designed code is superior to well-designed code that does not work, okay? And I mean that quite seriously. I would rather you break the rules for an assignment and give me working code than follow all the rules and give me code that doesn't work, okay? Try not to break too many rules, right? And of course, stuff like including vector. Even then, you're going to lose marks for that, but you will lose more marks if your code doesn't run, right? Yeah, if you have to break the rules to make it run, I would prefer you do that than to hand in something that doesn't work that's beautifully designed, okay? And because also, large language models can beautifully design code that doesn't run. And so we will also want to avoid that. So, and here's the thing about poorly designed code, you can fix it, right? You can refactor. I do it all the time, right? And in fact, let's use this server that I wrote over the summer as an example. I basically wrote the core of it in a week, and then I slowly added some features, but in the beginning, I didn't know what I was doing. And so I did not start with design at all, right? I wanted to figure out, can I do the things I want to do, and how do I do them? And the things I want to do basically are like download student. The thing I did was made a web page, a very simple one, and then there's a button that I can attach a file to, and it would download it into a certain location. And all of that was just in one big JavaScript file, right? I didn't use good design. I didn't use any design patterns. I only added abstractions when I had to because I needed to figure out how this stuff worked. I needed to debug it first. So I wanted my code that actually did the thing I wanted to do in the context with as much context as possible. So when I'm debugging, I can see like, oh, it used this variable and this variable's over here, and here's how it was initialized, etc. So design patterns actually get in the way in the beginning. Once I was confident I could download your code and run, a Python script on it, then I abstracted that away into its own file and module. All right, so yeah, we talk a lot about well-designed code, but like, yeah, make sure it runs. Like that's the goal here. All right, we're also going to talk about, well, as they get bigger, all of these things become more difficult. So certain practices help us maintain a code base that is, still serviceable, still easy to modify. And so we're going to do that, we use testing, unit integration systems testing. So there's a lot of tests. I write a lot of tests for you, right? So not even the greatest tests. We're going to talk a little bit about testing, and I may even have you write some tests on your assignments. We're just going to touch very briefly on it. Again, you could do a whole course on testing, and we do actually, 4004. So we're going to modularity. So basically, if I have a bunch of code that works on the file system, then I kind of put that in its own module, right? I don't need to mix that up with my other code. And that helps me to be able to debug it and understand my code easier. Documentation, is your code readable? Do you have documentation for users? So in terms of, I'm not really going to enforce comments in your code. In fact, I prefer code without comments. There's a time and a place for, like, I prefer, let's say, a Java doc, even though Java doc's generated from comments, right? So, but those are special comments in Java. So in Java, you use a special comment, and then you say, you compile the Java doc, and it makes this nice HTML file, sort of like wiki. And it has all the explanations for your class and then connections to other classes. Beautiful. I much prefer that, right? In the code, I don't want too much stuff. And especially so if I write a complicated piece of code, I often add some comments because I've had the experience of writing code and then coming back to my own code a year later and going like, what did I do here? Like, I have no idea. So yeah, you should think about the next person that's going to read your code, who might actually be you, and will they understand this? So I will add comments for stuff like that. But my favorite comment is just readable code, right? Don't use a variable called SN, use a variable called student number, right? I can read that and see. I don't need a comment on like a getter. I know what a getter is. I can see how you've done it. I can even see if you've done something a little strange, like double check the value or whatever, right? So in this class, at least, we are going to be sort of worried more about having readable code, self-documenting code. That's going to be sort of the push here. And in terms of documents, well, like specification, that's the document, right? I've already kind of done all the work for you. You're going to follow the document and produce the assignment. So yeah, is your code readable? That's the main thing. Add comments, for yourself or for the TAs. If you think that the TA will read it and not understand it, then maybe add a little comment saying like, hey, here's what I did. I know it's a little, just a sort of, and then good, often well-established design, right? So for like, this back to the submission server, because it's the most recent thing I wrote. Eventually, it did sort of fall into its own design pattern, right? Which is basically the common design pattern of any node project. But, it has its own files, and you sort of, you have a configs.js and you have some views and you use like, anyway, you may understand that or may not, but that's I didn't reinvent the wheel. I just used a well-established design pattern that I knew would work. All right, we will shortly get into an example, I think, but our tools, the C++ language using a GCC compatible compiler. We'll talk more about that in a second. And we're going to write these C++ programs in Linux. All right, so Linux, you know, a brief history here. It's based on Unix, which was developed in Bell Labs. Yeah, I don't know the year. I have to look up the year. By Ken Thompson and Dennis Ritchie, and then Linus Torvalds came along and said, well, he was interested in systems level programming, so he was going to make a operating system, dominant operating system. And it's roughly Unix compliant. It's based on the same principles. Mac OS is Unix compliant. So there's a lot of things you could do in your Mac shell that are the same things we can do in our Linux shells, right? And if you go Windows, like ls and cat and things like that, if you go in Windows shell, that doesn't work. But if you go into PowerShell, I think those commands will work. So Linux operating system is modular, can be easily extended. You can add features. It's open source. It's free. It's designed for simplicity rather than being user-friendly. So if you don't have a user-friendly version, you might have to edit some configuration files and stuff like that. This is very friendly to our environment of developing C and C++, in particular because they were kind of developed together, right? So yes, C and C++ is going to work very well in a Linux environment. I do like some of these quotes, but I especially like this one, right? It was not designed to stop its users from doing stupid things, but also stop them from doing clever things. That also really aptly describes C++. Okay, it is a powerful language, and there's a lot of ways that you can shoot yourself in the foot, right? What they call them foot guns, I think, is the term. But if you use it wisely, then you can write really, really fast performance software. We're going to use shells, command line, right? So similar to the Windows command line, we will run commands to, look through the file system, execute programs, and compile things. So I want you to sort of, I know IDEs make all of this sort of easy. I hope, at least, that you use your IDE as more of a text editor, and then you do all these things from the command line, right? Because sort of marks associated with those things as well. So we will be looking for your knowledge of how to use the command line. Different shells. No, I don't know. I'm not a shell person. There are shell people who've used different shells and maybe have a favorite. There's a Bourne shell. There's the Bourne Again shell bash, which is what we tend to use in Linux. The difference between those, I could not really tell you. Right? As far as I know, all the commands that I've ever used on one will work on another. What the differences are, I don't know. Here are some of the commands. You're going to see them in action. So list, change directory, make your file executable, chmod plus x file name, things like that. So we will use some of these. Cat and grep. Grep is particularly powerful if you know how to use it. There's a lot of things in Linux and Unix and like Vim. If you ever watch, if you were ever in one of Christine's classes, she's like a wizard with Vim. So these people can do magical things from the command line. I'm not one of those people, but one day maybe. We're going to use text editors. In particular, well, this is more of a little more than a text editor, right? It's an integrated development environment, which means there are more tools attached to this. You're free to use whatever you want. I sort of suggest Visual Studio Code, even though I feel like it was once a great thing because it was very minimal. And now it does, now every time I open it, it tries to sell me Copilot. which I don't appreciate. But, so it is becoming a little bit bloated, but I still think it's one of the best tools that we can use. And we're going to use these to write programs and make files. So why Visual Studio Code instead of something like Atom? They look very similar. Well, Visual Studio Code has a nice thing where it kind of runs the compiler in the background and then gives you like these the little red squigglies, right? Say, hey, you did something wrong. I like that. C++, the compiler is not to communicate with, right? It sometimes gives you some wild error messages. The compiler, the GNU C++ compiler, the command is G++. We were going to run it from the shell. That's how I recommend it. Nothing we're doing is going to be difficult. I recommend learning it because it will help you in the future. We're going to use the current, so this is OpenStack is running Ubuntu 24.04. And if you run the G++ version, I think you get 13.3. Anything over 11 is fine. Okay, so don't really worry about getting this exact thing. Almost any version of Ubuntu or Linux Mint or those types of Ubuntu-based operating systems will be fine. So if you have any of those things, our code should run. Technically, the assignments and the tutorials must run on the OpenStack or the course VM, right? So those are the same image, so to speak. I've never run into any problems. So anything Ubuntu 20 or later, you're probably fine. So how do we, all right, so let's talk a little bit about our programming environment. Most of you will probably use a virtual machine. Yeah, you can use G++ in the VS Code shell, for sure. The VS Code shell is just a shell. It just happens to be in that VS Code window. Maybe we'll look at it. So yeah, most of you will be using the virtual machine, so VirtualBox. And then if you have something set up for 2401, that will work, almost certainly will work perfectly for this class. So you might already have everything set up. If not, you go to the Carleton website, look up Carleton virtual machines. It'll take you to the appliances. You can, depending on how Andrew names them, sometimes we have our own version which you can download, but if you don't, 2401 works well. We can also use, I'll talk about this in a second, but let's talk about the Mac because, well, I don't know, you would have to try it out, but in past semesters, if you have a Mac with an ARM chip, so that is one of the M series, it will not run VirtualBox. So how many people have a Mac with an M series chip? Couple, all right. So your solutions, your possible solutions are, and there's a couple here that I haven't, that are sort of new to me. You can just use your command line. Okay, that's gonna work pretty well. There's a couple of differences. One of the big differences is you won't have valgrind. So valgrind checks for memory leaks. There are other memory leak tools that you can use, right? So built into your Mac is a compiler called Clang or CLang or whatever you want to call it. I like Clang. It's a drop-in replacement for GCC. You will have to do something like, what's the exact? I think you'll have to add a flag when you compile, and I wish my pen was working. I think the flag is something like this to make sure that you are minimally using the C++ 11 version of the compiler. If you don't, then you'll run into certain problems. Some stuff will compile, but some stuff won't. Okay, I think I might have a Brightspace page on that. If not, well, I'll check and see. I have a Mac at home, but I don't use it very often. Well, it's my wife's Mac, right? So she uses it. She doesn't really program on it. No Valgrind. What else? Oh, yes. Windows subsystem for Linux. That's probably what I'll show you today. It works great. Yes. Oh yeah. Okay, sorry. Yeah, let's stick with Macs. So one solution, use your command line. It's not ideal, but it will work. The other solution is make an OpenStack instance and connect to that. Okay, and that's a little bit of trouble to set up, but the instructions are very, very well laid out, right? Andrew did a fantastic job. Even if you don't understand what you're doing, you just follow them. There's a bunch of videos. You will be able to set up your OpenStack. Once you have an OpenStack instance, you can SSH into it. So I can open my command line, I can SSH into it. Can I do, yeah, I can probably do that here. So this is one of my OpenStack instances. Trying to remember. I think it's this. It doesn't look right. Oh no, sorry, it's this way. And then you put in your password. And then lo and behold, this is actually running on a computer here at Carleton, right? So if you set it up, make sure you also have to set up your VPN if you want to access OpenStack from off campus. And the only reason I bring that up is because to access your VPN, you need two-factor authentication. And to get two-factor authentication, you have to talk to a human being here at Carleton. So you can only do it Monday to Wednesday, or sorry, Monday to Friday. And so you can't do it on the weekend. So if you leave your assignment to the last minute and you don't have your VPN set up, well, you're out of luck. You can't do it on the weekend. So yes, OpenStack works great. And even from here, right? So let's show you the, just for fun. Well, this is a, you know what? Let's not do that in case I accidentally give something away. Let's connect to something else. But you can set up your SSH from here. So let's go to, I don't think that one's still running. Let's go here. Okay, so I'm going to, this is exactly the same thing that I just did from the command line, except VS Code allows you to do it. So I'm going to enter my password. Oops. And then I'm going to open some folder that, let's see here. Okay, I can open documents. And now, oh, I have to put in my password one more time. Yes. Okay, so now I'm in a documents folder on my on my stack. I've SSH'd in, and now I can just add, main.cc. I can write programs, and I can compile them, and I can and it's as if I'm working on my own computer, right? So once you set it up, OpenStack is very nice to use. You just need the VPN, and so yeah, anybody who needs help with this, you can talk to the TAs or myself, because again, especially if you're running a Mac, this might be your best option, and it's a little bit of a pain to set up, but once it's set up, it works beautifully. And somebody asked, does OpenStack ever go down? And well, it runs in the server room in Hertzberg. So if the power goes out in Hertzberg, OpenStack will go down. If that happens, though, if it happens near a deadline, I will extend the deadline. It doesn't happen very often. CPP, yeah, we're going to talk about that. So yeah, OpenStack, a very viable solution. I will We'll see. Maybe we'll do that. Okay, so we talked about OpenStack. Oh yeah, one more thing. If you have a Mac, this I have not tested this, but somebody mentioned it in the other class. This is called UTM. It is a virtual machine, like a virtual box, virtual machine running appliance for your Mac. Apparently it's free. Apparently you can download and run Ubuntu on it. I'm not sure if it uses the same virtual machine. Like if you can download Carlton virtual machine and into the thing, I'm not sure. I just heard about this thing yesterday. Somebody said that they were using it, so apparently it works, but they didn't use a virtual machine from the Carlton website. They just downloaded a version of Ubuntu and installed it themselves, which is probably going to be just fine. Maybe even better in some ways. All right, so yeah, if you have a Mac and if you have an M1 chip, those are sort of your options. And your best ones are probably OpenStack, or if this UTM thing works, then that's going to be also a very good option. Okay, questions? All right. If you're on Windows, well, VirtualBox is going to work. The other thing is Windows Subsystem for Linux also works really well. It's credit where credit is due. That is basically you can go to the Windows Store and you can, for free, get Ubuntu. Now there's a few steps to setting it up, but the last time I tried it, Windows walked through. So you go to the Windows Store. Right, do we have it? You look for Ubuntu, and I can get any one of these. And then I'll download it and I'll try and run it and it'll say, oh, it's not running because you didn't like enable your hypervisor or something. But the instructions on how to set it up are pretty clear. I actually have it. So if I go Ubuntu 22.04, I open it up, it opens a shell. That shell might take a little while to set up. But there we go. So now I have a Linux command line, and I have some sort of, like there's a Linux file system, but I can also go to my Windows file system and run, I can run the Linux version of GCC on my C++ files and then run them from here. So it's as if it's running in a Linux environment on my Windows machine, right? This is basically like a virtual machine. But one that kind of sees all of your files in Windows. Okay. So yeah, those are a bunch of options. Hopefully I didn't throw too many out at you. So Mac M1 chip, that's sort of, those you're gonna have to make some decision about how you want to, which sort of, none of these are ideal. The best one is probably OpenStack, right? Well tested, works great. Or if you're on Windows, you can use the virtual machine or WSL. All right, questions? All right. Code in the same environment that executes. So when I go to my Windows shell and run my Windows subsystem for Linux. Why is there two of these? Oh, that was my, yeah. When I go here and I compile, it compiles it for a Linux system. And if I use the Windows shell, well, I also have a GCC compiler for Windows, but if it's going to create a .exe, and they are not compatible. Okay, so if I compile in the Windows system, it can only run on a Windows system. If I compile on a Linux system, it can only really run on a Linux system. The one other gotcha in Windows, the file systems are not case sensitive, right? Something like room.cc, and then in my makefile, I write room.cc with a small r, then that's going to work on a Windows file system. And it will work even in VirtualBox But when you go to submit this and the TA tries to run it, it's not going to work. Right? This is going to give an error. So that's one of the gotchas. And if I do this, even in Windows Subsystem for Linux, even though this is a Linux environment, it is not case sensitive, right? So that's one of the gotcha things. But let's write some code. Let's make our first Hello World program. So I'm going to do it locally using Windows Subsystem for Linux. All right, so this, I'm just going to make main.cc. And yes, so .cpp is the sort of file marker that you will see everywhere else. So for some reason, Christine has been teaching this course way before I taught it. And so when they gave it to me to teach, I used Christine's materials, and one of the things she does is, instead of CPP, she uses .cc. I'm not sure where that came from, but I think it's kind of neat. We have our own little C++ culture here, right? So .cc, maybe it's Carlton C++, I don't know. Instead of CPP, you'll find C++, the compiler does not care what the file extension is, right? These are all text files. You can write whatever you want here. So we're going to use .cc for our convention. Okay, so we want to make hello world. So we're going to do include. We want to be able to write to the console. So we need the input-output stream library. Let's see. No. So yes. Is there any difference between the syntax for each extension? No. Again, C++, the compiler, does not care what the extension is. Right? Your IDE might. Your IDE will probably by default look for .cpp. But if you're using the command line, then you can just do whatever you want. These are all just text files. So as long as they read as text and the text makes sense, the compiler will compile them, whatever the extension. Okay, we need a main function. This is where our program will start always. So we need exactly one main function for each program. And well, there's one other line in here I'm going to put using namespace standard. We are going to talk a little bit more of that in the coming lectures. For now, just think of this as this is the standard namespace. And a namespace is similar to a Java sometimes my brain just flees the building. A Java package, right? So in Java, we have packages so that we can. So I might have a point in my 3D game package and a point class in my 2D game package, and they're different. So if I want to be explicit about which one I'm using, I include the package name. And this is the same thing with this standard namespace. So here I'm saying I do not need to use the fully qualified name for these things that I'm going to use. So one of the things I'm going to use is the standard output. It's going to take a stream. This is the stream insertion operator. I'm going to say hello world. And then I'm going to do an end line. So this is different from printf from C. Well, let's just run it and make sure that it works. And then we will talk about some of the decisions that we made here. cd temp. Okay, so if I list, I have main.cc. I want to compile that g++ main.cc. Oh boy, it's much faster today than it was yesterday. So when I compiled it, it gave it some default name a.out. So a.out is what's called an executable. It's a binary file, so it just has a bunch of structures that our CPU will understand. right? So it's a bunch of binary. If I tried to open it, it would just look like nonsense. But I can run it. Now to run a binary, I just write the name of the binary. There is a caveat to that because it says command not found. So when I write a command, it doesn't look actually in the current directory. It looks at the path variable, and the path variable has a bunch of folders where we store our binaries for that system, and these become commands. So it looks in all those folders and it says, I don't see an a.out. So I have to tell it, oh, actually look in this current folder, which is the single dot. That is the current folder, a.out. And then it says hello world. Okay, so that's it. We've written our first program and we've run it, we've compiled it, we've run it. We're gonna talk about all of these things, but any questions before we dive into more detail? Okay, well, the first thing, a.out is kind of a silly name. Let's fix that. So I'm going to say remove a.out. All right, so a.out is gone and it's gone forever. All right, so be very careful with this little command rm. In a Linux environment, you can't take this back. There is no trash bin. There's no recycling. This is gone for good. Okay, so I've accidentally before removed my source files, and that was a very sad day. Luckily, I had some backups, but I did lose a lot of work. You can't get them back. Endline is like writing, yeah, exactly. With one little caveat. So first, let's recompile this using -o for output. I'm just going to call it main, and the input is main.cc. And now when I list, I have a main, and when I run it, I get hello world. So I can name my executables with the -o flag. Is this like the end line or the new line? Yes. In fact, if we do this, I almost wrote make, but and I recompiled. There's no difference. What is the difference? I guess offhand, does anybody know? Yeah. Yeah, it also flushes the buffer. Now, there's a caveat to that. So this class, I'm going to tell you a bunch of, let's call them useful lies, all right? They're useful lies because, well, A, they might not be true. The version might be different from the version that I last used. So they may have made changes. The other thing is that none of these are really, like C++ is not a compiler. It's a specification, right? C++ is a language specification. So people that are, really smart with this stuff decide what goes into the language, and I say something like, well, if you do X, it's Y should happen. And then the compiler people go, and then sometimes, they might make a prototype compiler as well, right? So they have, and how you can do that is this way. But the people who write the compilers are free to do it any way they want. So I'm going to say stuff like, well, when you make a class, it's laid out in memory. Useful idea. It may or may not be true. It's probably true, not always. All right. So I am sort of, when I say these things, you should take them with a grain of salt. They may not be exactly true, but they are useful ways to think of things. So yeah, this, as far as I know, is if I do just the new line, let's say I do new line, and I believe I've also had this happen, but again, they may have updated the language and it may behave differently now. So I do a new line and then there's a crash that happens down here. Well, what happens is this may not get printed to the screen, right? So every time I send things to the standard output, it doesn't get printed to the screen right away. It goes into a memory location, right? A buffer. And it stores it there, and it waits for a bunch of stuff to accumulate, and then it prints it all to the screen at once. That's more efficient. The problem is, if I'm looking for this crash happens, and this didn't get printed, so I'm looking up here for the crash, right? Crash. Because I think this line never executed. It did execute, actually, but it got stuck on the buffer. So this is actually the more efficient way to do it, but what I would advise, and what all the examples will sort of use, is the end line. It inserts the new line character, but it also flushes the buffer. And in this case, if there's a crash below, I am certain that this is going to print out, right? So then it's going to make this line, the line where the crash happened, easier to find. Incidentally, when you're debugging your code, that's the first thing you should do, right? Oh, it crashed. Okay, so I'm going to go to the TA and ask for help. Well, what line did it crash on, right? So find that out. Use either print statements, or if you're into debuggers, you can use a debugger. I think debuggers are kind of heavyweight for this sort of thing, but people love them. I see why. Now, we'll talk a little bit about debuggers maybe later in the course. But yeah, try and find the line number. That's a great starting place. What line did it crash on? And then you can start to like work backwards to like, oh, why did it crash here? Some data gets corrupted, or you've accessed a pointer that was never initialized, or something. All right, questions? All right, let's talk about this using namespace standard. What happens if I get rid of it? Oh, well, this is why I like VS Code, is that I don't have to run the compiler to find these errors. Tells me right away that, hey, the compiler doesn't recognize this cout character. Why is that? Because I did not use the fully qualified name. This is actually in the standard namespace, there is this cout object. And so I'm going to use what's called the scope resolution operator to give the fully qualified name for this cout object. And actually, if you're writing C++ code out in the real world and not in academia, this is what they expect you to do, okay? Scoping in the standard namespace is bad practice because the reason why we have these is to avoid naming collisions, right? So they are actually useful. We're going to basically, one of these days, I'm going to go through all the examples and dig out every instance of this. But for now, we're kind of stuck with using it. It can cause problems, which we'll talk about also, but I can, if I'm scoping in the standard namespace, I don't have to do this, but I can, right? This is still fine. All right, how are we doing? 5 minutes. All right, questions? Okay, let's, for some reason I went slower in this class, I don't know. All right, so this is what we did. Sitting here, we wrote some C++ code, we sent it through the compiler, we got an executable out, it's a bunch of bytes that the CPU can understand, roughly based on assembly language. As programs get bigger though, so that compiling happened sort of fast, like kind of slow actually, but for the size of programs that we use, you're not going to notice any compile times. But in the real world, when you compile big programs, they might be hours to compile. And so what we want to do is we want to split up our code into different files and compile them individually, and then what's called to link them together, right? So, and what the effect of that is that if I need to make a change just to one file, then I just have to recompile that file and then relink everything, and that's a lot faster than recompiling everything. But let's quickly run through an example. Let's say I want to make a second function, hello from foo. Oops. And I'm going to call that from main. Okay. All right, so hello world and hello from foo. That works great. So my program is getting more complex. I have a second function. I don't like the look of this, and this is, you may remember this from 2401. So let's say I still want to keep the main at the top. I want to put foo underneath. And then when I try and compile, of course, it says, what is this foo? I don't know what you're talking about. So the C++ compiler is very, very dumb, I'm going to say, but like naive, very straightforward. So when I compile main, it starts reading here. It says include IOStream. Okay, so it brings in this and this. Use the namespace standard. Okay, so it scopes everything in, so I don't have to put this standard. And then it starts reading main, and it says, gets to here and says, yeah, all that's good. And then it gets to foo, and it says, wait, I've never seen foo before in my life. I don't know what you're talking about. This makes no sense, so I'm not going to compile this. Okay, so the compiler is very straightforward. It doesn't do anything fancy, right? And you have to keep that in mind because we're going to be compiling a lot of different files. And when you're tracking down these compilation errors, you have to think like a compiler and just kind of go straight through. So the solution is I'm going to say, well, Mr. Compiler, there is, goodness gracious, there is a function. It's called foo. It takes 0 arguments. It returns a void. And I'm not going to give you the code for that yet, but believe me, it's coming. Yes, in Java, that's correct. The Java compiler will actually do like a pass-through, and I'm guessing at least, and would read this foo and would remember it, and then it would try to compile it and say, yes, of course, I've seen foo down here. That's okay, yeah. C++, the compilers don't do that. For whatever reason. Probably, I don't know, maybe it's a little faster. I'm not sure, actually. But we can what's called forward reference this function. So I can tell the compiler there is a function foo. Here's what it looks like. I'm not going to give you the code, but this is all you need to verify that I've used it correctly, right? So the compiler gets to here and says, oh, you called foo, and looks up here and says, yeah, you used it correctly. I don't know what the code is. In assembly, this is some jump to some memory location, right? It's saying jump to the place where the code for foo is and start executing. So when the compiler first compiles it, it just leaves this blank, and then it gets down here and says, oh, here's the code, and then it fills it in with the memory location. Okay, so if we forward reference, it now works again. Oh my goodness. All right, questions? All right, so we're not going to write code like this, though. Actually, we want to put foo in its own file. I got 2 minutes, eh? Let's see if I can do something. So I actually want to put this in its own file and compile it separately. And well, now I don't have, well, first of all, the compiler's saying like, I don't know what this is, right? It's a separate file. It doesn't realize that it should be in the context of this. But let's just solve this problem and then talk about why this worked. So I'm going to say include foo.cc. And then I'm going to run g++-o main, main.cc. And it works. And why it works is because the compiler, again, is just doing the most straightforward thing. It starts reading. It says, import the IOStream, sure. Scope in the namespace standard, sure. Include foo.cc. So at this point, it stops reading here. It jumps to this file and continues reading. It remembers everything. It remembers the IOStream library, standard namespace. So when it gets to this cout, it says, oh, okay, no, I know the standard namespace is scoped in and we're using this library, so I know how to compile this. It's as if this was, in the first example, instead of include, I just put the whole function there. That's exactly what the compiler is reading. Okay, so this is how not to do it. It works though. And again, better that it works. The first tutorial will catch this though if you do this. you will lose marks. So next class, we will talk about a better way to do all of this, where we compile foo separately and link it, and then we can just, keep compiling separately as we update them. But that was class. Yeah, I'll see you guys. Hey, good. How are you?
For the OpenStack server, I tried setting up like my server so I can like run my own VM.